So today we want to look on cylinder block evaluation, and this part is not the disassemble and assemble of the cylinder block, is the evaluation. Where's my feeler gauge blade? Alright, so the first thing we want to check the cylinder block here for. Of course, we're going to inspect the cylinder block and look for if there's any crack or damage on the block physically. Alright, or any excessive corrosion in the water jacket. Look in the water jacket area. If there's any excessive corrosion, look also in the gallery if there's any sludge built up. If sludge is built up in the block, that have to be cleaned before the block is reassembled. And any cracks or anything like that will have to be replaced or fixed at the machine shop. Alright, so far, of course, we're going to feel right here if there's any lip. We're going to inspect inside the cylinder. If there's any physical damage, any scarring and marring or anything like that. Alright, so everything physically right here. Now we're going to use our straight edge and our correct size feeler gauge. And we're going to check the block if it warped. So we do it like this, no. You have to check the manual to get the correct size thickness of the blade. Like this, not going through. Alright. Alright, so the deck of the block is not warped. So we have to flip over the cylinder block and check the crankcase. Alright. Alright, so down here now we'd have to flip out these bearings, these main journal bearings, and we're going to just take them out in the order in which they came from. And then what we're going to check now, we're going to check the bore alignment. So let us check the face of right here. What? Good, let us check the face of right here. Need to check right here if there's any warpage. Wow, feeler gauge blade going through, so there's actually a warpage right here. See it? Yes, it is going through, so there's actually a warpage right here. Alright, let us check this side. So this will have to go to the machine shop. Alright. And this blade is a pretty thick blade. This blade is a pretty thick blade, and this is just a demonstration purpose. Check the manual. So there's a warpage right here. I'm not sure if that can be corrected by the machine shop. You have to go to the machine shop and they will figure it out. Alright, this is a bore alignment. If right here is out, the crankshaft can be damaged and the main journal bearings can be damaged. So I'm going to check. Alright. Alright, so we check the depth for warpage, we check the crankcase base for warpage, and we check the bore alignment for warpage using the straight edge and the feeler gauge. Awesome. So here we are now. We have this instrument right here which is called the bore gauge, and we use the bore gauge to measure two things. We use it for taper and out of route. Let us take a look on our board and let us get a basic explanation for taper. So basically, the cylinder is supposed to be parallel as much as possible. So this is a good cylinder. And the cylinder is supposed to be circular as possible. But with taper now, the top of the cylinder becomes extremely wide because of the piston rings, the compression rings forcing against the cylinder wall. So the top of the cylinder becomes extremely wide and the lower part don't wear, so the cylinder takes on a taper. The cylinder is supposed to be round like a nice ball, but after a while, because of the backward and forward slapping of the piston within the cylinder takes on an egg shape. So, this instrument right here, which we call a bore gauge, we're going to use this gauge to measure the taper on the outer round of the cylinder. So let us come back right here, and here we are now. the instrument already calibrate. Alright. Alright. Good. So I calibrate the instrument. Good. So when I calibrate the instrument, I want to put it at the top, ensure that the cylinder is clean. Calibrate the instrument right here, and I'm basically going to carry this. I'm basically going to move this up and down, and each of this graduation value 0 point, 0 point, this instrument not calibrating on me, 0.05, alright, so we're going to move this up and down the cylinder. If I pass 4 graduation, that means the cylinder is taper. I just pass 1. Alright, so this cylinder is good so far. So when it comes down to the taper, it is still within range because it's supposed to pass 4 graduation, because each graduation is 0.0005. Alright, so the taper is good. So let us try the outer flow now. I'm in the center. Let us try to rotate it. And well, it's not bad. You have to rotate the camera with me, because we are rotating now. And focus on the gauge. We are rotating now. Focus on the gauge. Alright, 360. Go around next side. Alright. Alright, so that's it. So for the most part, alright, just continue the gauge. So good. So it need to move out? No. Alright, good. So far, the taper on the outer round, it seems good. So this cylinder block so far, based on what you see, it will need to go to the machine shop because the crankcase have a wattage. But for the cylinder, it is good. No crack, no corrosion, based on the visual inspection that we can see. The taper is good, the outer round is good. The only thing I don't really check, I don't have an internal micrometer to check the internal wear, but there's somewhere we can check that. So the block itself is good now. Let us move on now to the crankshaft evaluation. Alright, so here we have our crankshaft evaluation. And we're going to check the crankshaft for several things. Look here on our board. We want to check the crankshaft for straightness. We're going to use our dial indicator and our V block. We're going to also the crankshaft journal for taper and outer round, where we're going to use our vernier caliper. So the shaft supposed to be parallel like this, but because of wear, it take on a taper shape. The shaft supposed to be circular, but because of wear, it take on an egg shape. So when we are checking our crankshaft straightness, we're going to use a dial indicator, V block, very important. When we are checking our crankshaft taper, we're going to use our vernier caliper and check the front and the back, and we're going to check our journal for taper by checking the top and bottom and the left and right. And normally, people, when we look on these shafts, we normally have a tolerance. So ensure that you should be able to do some decimal calculation. Alright? So here we have our crankshaft, and here is our V block, and here is our dial indicator. What I'm going to do, the same way how I use the bore gauge, I'm going to rotate this crankshaft after I calibrate it with my dial indicator. And when I rotate it, the needle not supposed to move no more than 2 graduations. So let me just rotate this and see if my needle moving any at all. Well, my needle is slightly moving, but it is not a lot. Alright, so the straightness of this crankshaft is good, and of course, with everything that you're checking, you have to check the physical characteristic of the shaft. Let us look on it. If there's any breakage, if there's any cracking, if there's any excessive marring on the journal, all these things we're gonna look. We're gonna look on the snout of the crankshaft. We want to look on the flange of the crankshaft. We want to look on the main journal. The main journal is this journal right here that goes straight through the main journal. We're going to inspect the holes if there are any sludge built up. We're going to inspect the web if the web is in good condition. So far, physically speaking, this crankshaft is in good condition. All right, let us check for taper. And even before you check the crankshaft for taper, you have some time you can visually inspect a bearings. And you can see, look on these bearings. Come, let us look back on the taper. You notice when a shaft is excessively tapered, one end of the shaft is extremely high and one end low. And if you should look on this bearing right here, the impression on the bearings, we can see that one end of the bearings right here is wearing and one end of the bearing is not wearing. So looking at this connecting rod bearing cap, we can tell that the crankpin journal of this crankshaft, that these connecting rod bearings came off, it was tapered. So that's why it's very important to check the taper card. Taper journal, taper conrod, crankpin can damage the bearing. So let us check just one journal. So I'm going to check the crankpin journal, because the crankpin journal is normally the journal that experience the most wear. So I'm gonna measure it at the front. It depends. All right, right here. Measure it at the front right here. All right, measure it at the front. Tighten. Good. Feel a little tightness. No, I don't like how this feels. Yes, measure it at the front, and then I will just measure it at the back and try to feel the same tightness. And once both ends have the same tightness, that means there's no taper within the journal. There's a small amount of taper once we have the same tightness. If we find one part tight and one part loose, then we'll have to actually take a reading, do the subtraction, and find out if the taper is within range, because anything over 2,000 of an inch need to go to the machine shop for it to remachine. So far the taper is good right here, and each journal should be measured for taper, each journal. All right, so let us try the out of round now. So the out of round, remember, we're going to measure the top and the bottom. So top and bottom. Good. Tight and gummy. Then we measure the left and the right. Good. Tightness. Good. Tightness. I can feel the tightness on the vernier caliper. So what that is telling me, that this journal right here is good. Piston and the connecting rod. Of course, remember we have two type of well, here we have the piston, we have the grudgeon pin, and we have the connecting rod. All right, so piston, grudgeon pin, connecting rod. All right, this piston right here now, generally when we remove a piston, we have to ensure that we put the piston in its correct position. We mark it. We have to inspect the groove, or the groove, the ring belt of the piston. I'm going to do a specific video on piston evaluation. All right, we have to inspect the rings, ensure that there's no carbon deposit to do the cleaning up. And remember, we have two types of grudgeon pin. We have floating and semi-floating. Remember that the fully floating is the one that the grudgeon pin can spin both in the piston and in the connecting rod. And with the fully floating, we normally have a circlip to hold the grudgeon pin. But with the semi-floating, the grudgeon pin can only spin in one component, and in this particular case, the grudgeon pin can only turn in the piston. So therefore, the Gudgeon pin is tight fit or interference fit to the connecting rod. In a situation like this, we'll have to use a press and extract this gudgeon pin. Alright, the other thing we need to notice that we need to inspect the piston skirt for any excessive wear. We need to inspect the groove belt for any damage, the piston crown, and all these things. But I'm going to make a video on piston evaluation. So far, in summary, we have looked on the cylinder block. So in summary, we have looked on the cylinder block. We have looked on the deck. We have checked the deck for warpage. We have checked the bore alignment. We have checked the crankcase. We have do our visual inspection for corrosion, crack, indentation, marring, scratching, such like. We have evaluated the crankshaft using our dial indicator and V-block. We have checked the journals of taper and outer row. So the next video, we want to look at things like the cylinder, like we look on honing, piston and rings removal, and we're going to look on the oil pump and those things. So that's it for now. Thanks.